Hello everyone, this is Tgrip. This is part 2 of the TryHackMe horror machine walkthrough. So I'm going to be showing how to do a privilege escalation from the point where we last left in our first video. So let's begin. So we were here where we had bypassed the Nginx logic using the X forwarded for header, and we were able to send a command and get that executed. So the next step is to get a shell on this machine. So I'm going to try and use some of the reverse shell one-liners. Okay, so I'm going to turn off proxy and go ahead. Search for one-liners. I guess, okay, there's something going on with the site. So, but I'm going to use this. And quickly, you can find a bunch of them. I'd like to use the basic bash one. So take that and let's see what our IP is real quick. And it hasn't changed, so that's very good. So I'm going to replace my IP here with this, and let's listen on port 443. And just for the sake, since we are sending a web request, it's always good to URL encode that. So what I did is Control U, but you've noticed that the ampersand symbol was changed to %26. That's not something that will work for us, so I'm going to keep it at ampersand. The rest all looks fine to me. So before sending the request, let me listen on port 443. Okay, it's already in use. Keep getting that. I'm not sure what other tools of mine are using them, but anyways. So we have port 4443 and send, and we have nothing. So the next step is to make sure an outward communication is even allowed on this port. So I'm going to try see if they have netcat installed on it. So do netcat space this and just URL encode it. Start up the listener, and we see a reverse shell. It's not a reverse shell. We see a connection from the machine, but it's killed once it reaches our machine. So that means something is going on the machine that's preventing us from getting a shell back. We could try to execute what can we maybe bin shell, because sometimes you won't find machines having bin bash installed on it. So let's try and execute this again and see if we have a shell. So it looks like we have a shell, but let's see. Yeah, so we have a shell on the machine. The next step is to upgrade the shell to in fact, let's see, who am I? And we see this. So let's upgrade this shell to an interactor reverse shell. So I'm going to use Python, and I'm going to import pty. I'm not sure what pty is if it's even correct pronunciation, but I'm just going to say it's pty. So I'm going to use bin bash and see if it's there. If it's not, we're going to use bin shell. Let's see. Looks like it's not present. So let's copy this. You know what? Just check for that and say which bash. We don't have it. Which shell, and we have shell. So let's copy paste that here and use shell. I really want an interactive. Okay, so I'm not getting it, so let me try this again. I got it. Okay, looks like we have to work with this kind of shell, which I hate, but you know, that's all I have. You could always go and upgrade reverse shell. So you could try a bunch of these steps that they show here. Python is the one we used. We see if we have SOCAT here. So we use SOCAT. We don't get anything. And netcat. Nope. Oh, actually, we can try and see if we have netcat from here, because we were not able to netcat. I mean, that's all the same. Never mind. So let's move on with this and just try and focus on what we're trying to do here. So next step is to run a PrivEsc script. So I'm going to use lin piece for that, which you can get downloaded from here. Take the raw version and use wget to download that to your machine. Make sure it's present. Okay, so I'm going to use Python HTTP server to download that to the victim machine. So use Python 3 http.server, and I'm going to listen on port 8000. And what was our IP? 1068.225. So just copy that, and let's go to /temp on our attack victim machine. Just ls. We see a bunch of files, but let's download that file here. So address, and it's linpiece.sh. Let's see, we get something here. We didn't get anything. Let's see if we have. Okay, we don't have wget. So we'll see we have co. We don't have co. But we do have netcat. So we could use netcat actually to send a to actually send a file through the TCP connection. So I'm going to listen on port 4444 this time, and once the connection is received, I'm going to send linpiece.shell to that. So I'm listening. So once I connect to my machine on port 4444, I'm going to receive the linpiece.shell shell script. So I'm going to save it in linpiece.sh. So we don't see anything coming here. Okay, I guess what's happening here is we were able to use netcat here, but not here because it's not present in our path for some reason, maybe. So I'm going to list the bin directory and grep for netcat. Find it here, and do the same, and grep for wget. Okay, I'll try one more time and we'll move on with another approach if we don't find it. So let's go to user/bin. Oh, looks like we don't have anything, or our shell died. I guess that's what happened. Let's close this and see. Yep, looks like our shell died. Okay, something is going on. Let's try again. We see the, okay, we get the connection and we were able to list. So let's list /user/bin, and we'll do that again and grep for netcat, and we do have netcat, so let's use that. Copy netcat, copy the path to netcat and enter our IP and can listen on port 4444. So let's put that here. And once it receives a file, I'm going to store it here on temp linpiece.sh. I'm going to rerun the script, this command, sorry, and we'll see if we have it. Will show it does get the file from this attacker machine this time. So looks like we can cancel it so that we receive the control back here. And again, we lost something. But we do have the linpiece script this time downloaded. So next step is to run the script. I know we don't have bash, I guess. So my bad. So let's change mode to execute for linpiece.show. Okay, we'll do ls.l so that we get the executable. Okay, so next step is to execute it. You might not find this the output very useful, but sometimes you do find certain things that you otherwise will miss out. So let's take a look. The reason why I said you might not find this useful is something I want to tell you in a while. So because this script primarily runs with bash really well, but since we are running it with shell script, we don't know if any of the commands or any or some of the commands did or did not work. So that's the reason. So but anyways, let's move on, take a look, and as it says, anything in red with yellow background is a 99% privilege escalation vector. So let's look for these and these, right? The one in red and yellow with red. So let's scroll down real quick. We are in a Docker. Okay, so that's interesting. So we are in a Docker, and what's that? We have root running certain commands. That's the PHP application. If you remember, it said the application was PHP FPM. So if you go here, I'm not sure what's happening, but let's do HTTP. Oh, I hate this. So let's try again. Oh man. So, the best way is to just use the IP of the machine. So let's take this. Yeah, so if you see here, it says it's powered by PHP FPM, and we find the process running as root. So one thing to note, let's move on. Okay, we have to be root. That's not useful. You can't write on system path. And okay, so here's what is interesting. We have port 9000 on the local running and listening for connections. So let's make a quick note of the observations here. So let's clear text and make notes dot text. Okay, running inside Docker and local port 9000. It's listening. Okay, let's move on. And for this 40,300, so let's make a note of that as well and move on. So we have EVS as the user. Okay, so looks like we can actually try to log in as EVS because we did have the credentials. So real quick, I'm gonna use the cred.txt file that I created to. So we had the web shell creds. So let's try and see if this works to SSH into the machine, because we know that we have port 22 open on this. So let's real quick take a chance here. I'm able to use this domain name because I saved the domain name into the etc host file. If not, you'll have to use the IP. So it says cannot. So let's try. Let's look into the etc host file and see what I missed. Horror.local should have been there. Okay, it's not there. So let me add it. Horror.local and SSH again and paste. Okay, so looks like the password is not valid. Okay, so let's move on. That wasn't, that was just an attempt to see if we can actually log in. I did not hope that to be that simple. So, anyways, we have the config file here. Usually, configuration files might have some sensitive information or anything that's useful. So, I'm going to create an entry for this here just in case if you want to take a look later. And yep, we can log in as root. And what else? We have CS certificates. That's okay. That's fine. It looks like we don't find anything. Okay, we do have /www, and we would like to take a look there because it's a web root and you might have configuration files that have passwords in them. So let's make a note and let's see. We have, okay, GPG keys. We have these two files right there. I don't think they are anything that they don't have any keys, but anything. Anyways, we'll just keep a note. Okay, writable folder. Okay, log rotate, but it says log rotate not found, so not even bothering to take a look into it. Oh, that's interesting. So if you look here, we have backup files here at etc periodic. That should be interesting. So let's take a copy of that and paste it right there. In fact, I'm gonna make it important, saying, hey, try this out first, right? Because if anything that's not usual on the Linux system or anything that's created by user have always proven to be having some kind of vulnerability or helping us getting our way into the root. So that's why. So keep going on, and yep, we copied the file and we have logs, but I don't think we will be able to access this because we are not in the log group, log readers group. So I think that's it. Nothing else stands out to me at this time. Maybe I will want to take a look into the secret.php, but I don't find this here because secret.php should have had some secret that they must have used to create the HMAC, but we did bypass it. So uh, anyways, that's all we have here. I think I have my shell back. That's very good. First thing, I'm going to take a look into this file because it really stands out and appeals to me to kind of, let's see if we can take a look into it. So let's read the permissions on the file, and we are able to read, or yeah, looks like we can read the file because it's owned by www. We are www, so let's catch the file. Okay, that's interesting. So we have the password for EVS. Is that the same as this one? It's 9F or E, and it's U. Okay, U6. Looks like SSH passwords to me. So take a copy of that, and let's exit this and try to SSH. You know what? I'm gonna keep this open and open the SSH on the next one. So paste. Okay, so we are logged in as EVS or EVS, whatever. You may change this message by HC mod T. Mod T stands for message of the day, and this has proven to be a PrivEsc vector in the past when I had done another machine. So I want to save this right there. You know what? I'm going to create a new line for PrivEsc and save this right here so I'm not confused later. So since we are logged in as EVS, we should be able to fetch the user flag. So I'm gonna switch the user home and list the files there, and we have user.txt. So we should be able to read the file. And I'm not going to do this, so let me move on to privilege escalation. So since we have now a higher privilege, let's go to the temp directory and rerun the Linux linpiece.shell file, because we might find some things we missed on the lower privilege enumeration. So off the bat, we see a bunch of red warnings or files here. That's really interesting. Copy all of them and put that in the note. Okay, saved it. Okay, let's take a look into this file. I'm gonna actually stop this because okay, it stopped already, because this looks like it is meant to be a privilege escalation vector, because it's like only root owns it, but the EVS user can execute them. So that's pretty obvious and straightforward to me. So I'm going to take the chance. Let's take a look on all of these one by one. So we'll take a look at the shell script, because this is an executable and it also have the SUID bit set. So probably it's going to run as root, because it has the SUID bit set on the root on the user section. So this is the group, and this should be the this is the group. What it means now is the user or the owner of the file can read, write, execute with SUID bit set. So it will always execute as root, and this means it's gonna have the read and execute permissions for the user EVS and no permissions for any other user. So that's why we did not find these files in our enumeration as www. Okay, let's move on. Let's take a look on this file first and make note of anything we might find useful. Okay, first thing is saying if, okay, it's checking if the current ID is equals to 0. So ID will be equal to 0 if you're root. So it looks like if equals 0, then echo and do all this, or I guess it's not equal 0. Okay, so I was misunderstood on that. So let's try and run this right? So the minus equals means not equals. So that's why we see this message. So we're gonna have to be a root, or we're gonna have to run as the root. And this gives us the int because this script or this binary always runs as root. So looks like we need to run something as root always. So let's take a read on. Okay, it's going to run only as only commands which are encrypted for this user using GPG keys. And if you find here, we have the backup folder containing the public keys. So if you are aware of the basic cryptography, the private key always decrypts and the public key always encrypts. I mean, that's the basic usage. So if we are able to like set here, it only runs commands which are encrypted for root harder.local, which means it's going to use the private key of this user to decrypt and then run it. So if we are able to encrypt a command with this public key and it's pretty much says execute crypted, we might be able to escalate to root. So that's the theory. We'll have to first actually import our public key. So I think it's GPG import, and let's import this file to GPG. No command supply. Okay, let's run gpg.help. Let's see how to import or merge key. That's exactly what I did. I'm not sure. Okay, I missed dash dash import, I guess. I hate when it happens. So yeah, I missed the dash dash here. So let's do that with the double dash. Okay, it's processed, and my bad. So we have the public key imported. So we next have to encrypt a file that can be decrypted by root.harder.local, which means that we need to set the recipient to this user. So copy. Before that, we need to create a file. I'm going to create a file. Let's see. Let me see what I want to create. I will just do ID. You know what? That's the simplest thing that we can do to prove that we have root access. So I'm going to create ID into command and just list the command, and yeah, we have ID. So okay, I'm going to change the command, the file to execute. So let's verify if it's working. Yes, it does, and it's going to print the ID of the current user that's executing the binary. So the next step is to run it with encrypt that for the root user. And I think for this, the syntax should be dash dash recipient something. So let me check to save me from embarrassment. So let's see. Dash dash recipients. How do I find that? Okay. Dash R or dash dash recipient and user ID. Let's do dash R, and that's not what I wanted. I want root harder.local, right? Because that's what the script said. And what we need to encrypt is the command file. We'll see. How do we encrypt? Encrypt data is -e. Yep, I want to use this tree. Okay, so we have command.gpg. The next step is to execute this so that to run that the final script that is set to suid as root. So run this one, take that, put that here, and I'm going to pass the command .gpg as input. If you're wondering how I know this is the syntax, I will show you a bit. If you see, once we run, we are root. So UID is root, so which means that we are successfully escalated to root. But before I end this video, I'll quickly show how I know to run that binary, because it's basically it says right here, but I want to show you anyways. It says encrypt the file and run the command encrypted execute encrypted command.dpg. So that's exactly what I did right somewhere here. Yep, right here. So if you want to actually get a what do you call an interactive shell as root, I would change the command that as something like, let's see, instead of ID, I want to put something like copy bin dot shell here and to current directory, and we want to set the SUID bit to on that shell, or even better, I'm going to say netcat to me as root. That's the best option, right? So 225 at 4445 445 and execute bin shell, and I'm going to put that here. So let's verify. Yep, we have that, and let's quickly exit this and listen on this port. Okay, so as usual, what we're going to do is encrypt this file and overwrite. Yep, we want to overwrite. And next step is to run that with this. So make sure we have that. And we have shell as root. From here, we'll be able to cd to root and list the contents. We have root.text. So that's it, guys. I hope you really enjoyed this video and learned quite a bit, not just about solving the system and also the reasoning behind why I did the certain steps in a certain way. And that's all I intend to do. So if you like this video, please hit the like button and please subscribe and share this video to your network. And I will see you on another video with another good learning opportunity. Until then, take care.